Good afternoon, students. Welcome back. Today, in our tutorials, we are going to learn a new concept which is called as process state transition diagram. As you all know, in our previous tutorials, we have learned about what is fork, what is the fork system call, and how is the fork system call implemented, and what is the main functionality of fork system call. Now, in this tutorial, we will be learning about the process state transition diagram. As we all know, we have discussed what is a process in the previous video. A program in its running state is called as process. Now, we will be discussing what are the different states that this particular process will move on, as a result of which when it will start the process, when the particular process will get terminated, what are the different states through which this process will go on, and what type of scheduling does this process use while moving through the particular states. Okay, my dear friends, the process from its creation to completion passes through various states. So, whatever process it may be, the minimum number of states that a particular process should cross is 5. Now, whatever programs that you are writing in your online compiler, these all programs, when after writing, when you are saving those programs, will be going and they will be saved in the main memory. This particular program that which is saved in the main memory is called as a new process. Now I am going to show you the very important process state transition diagram, which is very important question in your university examination, or a very important MCQ question if you are a student aspiring for GATE examination. This is a very important process state transition diagram where there are 5 states, how a process from the new state will go to the termination state, how the process will be generated, everything we will be seeing clearly. Now, moving on to the new state. Whenever you type your code in an online compiler or any outside IDE compiler, and when you save this code, immediately this particular code will be saved in the secondary memory. This particular code will be saved in the secondary memory. Now, the code that is saved in the secondary memory will be picked up by the help of a scheduler. Now, you may have a doubt, what are schedulers? Schedulers are like some of the transportation cards, like you can define like them as transportation boxes that are present in the operating system, which mainly decide in which order the process need to be executed. Suppose, for example, I have opened a compiler, I have typed some 100 lines of code, and I have saved that particular code. Similarly, some other fellow had opened the compiler, he had typed the code and he had saved. You know, both of us saved the code at a time, and both of the code that we have saved have reached the memory at a time. Now, to avoid conflict between these processes, they conflict may arise like which process should go first and work with the operating system. To avoid this type of conflicts, there are devices which are there are helping hands which are called as schedulers, which mainly help to transport this process. They decide in which order, they immediately check in which order the process has arrived based on their timestamp, and they assign that particular process to the CPU, none other than we call it as an operating system. Mainly, there are 3 types of schedulers: long term scheduler, short term scheduler, and medium term scheduler. Okay. Now, moving on to the new state. Whenever a process is created it, and it is picked up by the whenever a process is created and it is picked up by the short term scheduler, so this short term scheduler will be picking up the process from the secondary memory and keeps it ready in the queue. So this long-term scheduler will play a very important role in selecting which process will come and spend its time with the CPU. Now once the process is selected by the long-term scheduler, this particular process is entered into the new state, which means that a process has been created. Now this process from the new state will be going to the ready state. A process for going from new state to ready state should acquire all the required resources, all the input output devices, all the required resources. When the particular process acquires only all the resources that it wants, and it has all fulfillment, it has fulfilled all the resources, then only a particular process can move from new state to ready state. Now the process will go and sit in the ready state, which means that it is ready for the operation to be performed with the CPU. Now, in between, suppose I have, let us take for example, I have three process P1, P2, P3. Three process have moved to the ready state and they are waiting for the chance to work with the CPU. Meanwhile, there may be another process entering which is called as P4, where P4 may be having a higher priority than all the other processes that are already waiting in the ready state. Now, now P1, P2, P3 are waiting in the ready state. What will happen is when P1 is getting a chance to work with the CPU, immediately before that there may be a process P4 which is arriving, which is having highest priority than these three. So immediately the all the three processes which are there in the ready state will be suspended and will be sent to the suspend ready state, which means that the incoming process P4 will be given higher priority and it will be scheduled or dispatched to the CPU. So process once entering the ready state is not confirmed that definitely the process that entered the ready state will get the CPU for its utilization. There may be a chance that there may be a higher process, incoming higher process with higher priority. Then this particular process that are already in the ready queue, ready state will be sent to the suspend ready, where they have to wait until this higher priority process completes its execution with the CPU. Then again they will resume their operation and go to the ready state. Now the role of long-term scheduler has been completed. Now coming on to the ready and run states. Now the short-term scheduler comes into action. So the process from the ready state will be taken to the run state with the help of short-term scheduler. So as you can see in the diagram, there is an arrow that is being connected from ready to run state, and on the top of that arrow, it is written scheduled by dispatch, which means that the process from the ready state will be taken to the run state with the help of short-term scheduler. I again repeat, friends, the process, newly created process from the secondary memory will be brought to the new state or will be brought to the ready state with the help of long-term scheduler. The process which is created in the new state will be brought to the ready state with the help of long-term scheduler (LTS). Now, the process from the ready state to work with the CPU will be taken to the run state with the help of short-term scheduler. Now, in the run state, the particular process that is being selected by the short-term scheduler will go and will start working with the CPU, will execute its work with CPU. Meanwhile, again there may be a problem that has been erased. You can see an arrow from run state to ready state written as priority by time quantum, which means that a process which is executing its task in the run state may be preempted back to the ready state due to the reason of priority by time quantum. As I have told you, if a particular process is being running with the CPU and there is a incoming process which is having higher priority than the already existing process, that particular process will be thrown back away to the ready state again, where the incoming higher process having the higher priority will go and completes its task with the CPU. That may be one of the reason. One more reason may be the time quantum. In order to see that all the process which are arriving need to get a chance to work with the CPU, there will be a time quantum that is provided to each of the arriving process. For example, there are three processes that are arriving, P1, P2 and P3. Now each of the process will be given a time quantum of 2 units, which means that when the process goes from ready state to run state, that particular process which had gone will only have 2 units of time to work with the CPU. Time quantum is nothing but the amount of time that is being given to the process to stay along with the CPU and execute its task. Suppose the 2 units had already completed. So, as the 2 units had already completed, it doesn't have more time to work with the CPU. Immediately after the completion of 2 units, that process will be preempted back to the ready state. Okay. Now there may be one more problem that will arise in the run state. Once the process has successfully entered into the run state and it is executing its task with the CPU, that particular process may be required by some input output operation. It may receive some input output request. So as we all know, as we all are familiarized by using with laptops and computers, it is the responsibility of the operating system to first fulfill the request of input output devices. So immediately when a particular process that is engaged with the CPU receives an IO request, that is nothing but an input output request, you can see that an arrow is connected from run state to wait by block state, where that particular process will be preempted and it will be sent to the wait by block state, and from where once it had completed its IO operation, it had satisfied the requested input output operation. Again, from wait by block state, that particular process will, upon IO completion, you can see there is an arrow connected from wait by block state to ready state. Upon successful IO completion, this particular thing will go and will reside again in the ready state. Now, let us see what will happen from ready state. From ready state, again, as I have told you, the short term scheduler will pick up the process and again it will give to the CPU, which is taking place in the run state. If the process had successfully executed with all the input output operations being performed and with all the time quantum being utilized, and there is no higher priority process interrupting in between, then the particular process that is assigned to the CPU will complete its task and will reach the termination states, which means that the process will complete its execution and the particular process will get terminated. So this is the entire process state transition diagram. As you can all see, this is a very important diagram. These are the different states where a process goes through, or how many phases a particular process goes before, from the state of new, before the process gets terminated. These are the different states through which the particular process will go through. As you can see, I have given an individual explanation for each of the state. It directly enters into the ready state and waits for the CPU to be assigned. The process which are ready for execution and reside in the main memory are called ready state process. As I have told you, the process which are ready will be waiting in the ready state. They are called as ready state process. There may be many process present in the ready state. So out of the many process, it is the role of short-term scheduler to pick up which process it wants. Okay. Now this is the explanation of different states. You can go through this, how the different is what happens. Whatever I have explained, I have just written in the form of content, where you can easily understand what will happen in different state. what will happen upon completion of the particular process, how it will get terminated. Okay friends, so this is the tutorial about different process state transition diagram and what are the different states through which this particular process will move. I once again thank all of my friends for sparing their time. In the next tutorial of this operating systems, we will meet with we will enter into a very interesting concept that is called as inter-process communication, where this inter-process communication we will see with the help of shared memory, message queue, and pipe, where these three are mainly used for the communication between the process. Now I have told that there will be process created and this particular process will go through these different states. Now how to establish communication between this process, this particular thing we will be seeing in the next tutorial with the introducing of the concept inter-process communication. Thank you friends.